Hello, class. I'm aware that the video called Statistical Significance of Experiment is a little difficult, and Sal, the narrator of that video, doesn't necessarily fill in all the gaps to completely give a full account of what his reasons are for doing simulations in the first place and what they tell us. So I've made this video as kind of a commentary on this other video that I've already posted. All right, and so I'm going to be going over the logic of simulations, why we do them, what they tell us. So let's go ahead and start. Take a look at it. All right, so let's say that I have 40 participants show up at my lab. I randomly assign each of those 40 participants to be in group 1 or in group 2. All right, so it's looking like I'm going to be doing an experiment rather than an observational study because of that random assignment. All right, here's 4 of the people that were randomly assigned to group 1, Kate, Andrew, Margot. And then here's 4 of the 20 that were randomly assigned to be in group 2. All right, now what I'm about to tell you is going to be a little weird. All right, don't freak out. Both groups received the exact same placebo sugar pill, the exact same pill. So in other words, I'm not treating Kate, Andrew, Margot any differently than I'm treating John, Lily, and Anthony. All right, everybody's getting the exact same treatment. So the only difference between Kate and John, other than what's going on in their own personal lives, is that I say that Kate is in group 1, whereas I say that John is in group 2. But there's actually no other difference than that. Okay, now in 3 weeks, I measure the weight loss of each person. All right, so and after I've measured the weight loss of each person, turns out that the people in group 1 on average lost 5 pounds, whereas the people in group 2 on average lost 3 pounds. Now this difference of weight loss, which is 2 pounds, all right, 5 pounds minus 3 pounds. So this group difference in weight loss is purely due to chance. Because remember, I treated the people in group 1 the exact same way I treated the people in group 2. So it's only a chance happening that group 1 just happened to lose more weight than did the people in group 2. Now, what other group differences in weight loss are possible? All right, other group differences in weight loss due to chance that are possible, and how likely or frequent are each of those kinds of weight losses? So this is where the idea of simulation comes to be helpful. So what I'm going to do is go through each of these 40 people, flip a coin to see if they stay in their current group or if they get switched over into the other group. So with Kate, maybe I'll flip a coin, it comes up heads, so she stays in group 1. When I get to Andrew, I flip the coin, it comes up tails, so I know that he's now going to be considered part of group 2. With Margot, I flip a coin and it comes up tails, so she's now going to be considered a part of group 2. All right, and so I do that for each of them. So we can see that John is now going to be considered a part of group 1. Anthony is now going to be considered a part of group 1 also, whereas Lily and Sheila are still considered a part of group 2. Why am I allowed to do this? Well, think about it. If there is no difference between the treatment of these two people, right? If the treatment given to the individuals in group 1 had the exact same effect as the treatment given to the individuals in group 2, all right, then any other division of these people in the two groups makes no difference. It doesn't matter whether I consider John to be in group 1 or to be in group 2. He got treated the exact same either way. He received that same placebo pill, so it doesn't matter whether I consider him to be part of group 1 or to be part of group 2. Okay, this might make sense to you guys so far. You just have no idea what's the point of all this? Where am I going with this? Well, so I've now made a new division. Okay, so the original groups uh, don't remain. All right, so Andrew is no longer considered part of group 1. He's now considered part of group 2. John's no longer considered a part of group 2. He's considered part of group 1. And so I've run now a new simulation. In this new simulation, now group 1 has lost 1 pound on average, whereas group 2 has lost 3 pounds on average. So we have a different difference. All right, group 1 minus group 2, we now have negative 2 pounds, whereas we had positive 2 pounds before. But this is still due purely to chance. All right, and so this is going to be this negative 2 right here. That's going to be the number that goes with this new simulation. This is simulation 1. Or you consider this to be simulation 2 and this is simulation 1. It ultimately doesn't matter. Okay. In Sal's video, he said that he did 150 simulations. 150 simulations. So here's the results of his simulations right here. In most of those simulations, the group difference was between like -2 and +2. This is where the bulk of the differences were. Very rarely did you have group 1 lose 10 or more pounds than group 2. In fact, that only happened once. Also, very rarely did group 2 lose 10 or more pounds than group 1. That also only happened one time. So in either case, you have a result that has a 1 in 150 chance of happening. That's less than a 1% chance of happening. Okay, so let's try and take a step back. All right, if there's ultimately going to be no difference in how you treat your people in group 1 and group 2, all right, I gave them the exact same placebo. All right, it's still kind of random which people are going to be considered part of group 1 and which people are going to be considered a part of group 2. All right, and but in most of those random assignments, your chance group differences are going to be like between -3 pounds and +3 pounds. All right, and very rarely are you going to get a difference that's this large. All right. Now, let's go and see why on earth this would be useful. So, same scenario, okay, but this time group 1 received a potential weight loss drug. That is, it might cause people to lose weight. We don't know. If it does, then it is a weight loss drug. But if it doesn't, then it's basically the exact same thing as a placebo. You just have another drug that actually has no physical effect on weight loss. Okay, so the question is the drug that group 1 received basically a placebo, or is it actually an effective weight loss drug? All right, so we do the same thing. We measure weight loss of each person after 3 weeks. Now, group 1 lost 11 pounds on average, whereas group 2 lost 1 pound on average. This difference of 10 pounds may be due to chance. All right, if it's due to chance, what that is saying is that this drug is actually just a placebo. It doesn't actually have any physical effect on weight loss. That's the only reason why. And so group 1 having lost more weight, that was just a chance happening. This drug had nothing to do with it because it doesn't help you lose weight any more than a placebo does. All right, so this difference may be due to chance. It may be the case that this drug is just as effective as a placebo is for weight loss. Okay. What is the likelihood? All right, what is the likelihood that this difference is just due to chance? So I'm going to go ahead and do those simulations again, where I now go and say, Kate, I'm going to say you're part of group 2. Andrew, you're going to stay a part of group 1, but Margot, you're now considered a part of group 2. I do that. I get these simulations. All right. And look at this. Only one time, only one out of those 150 times did we get a weight loss difference this big. All right. Where group 1 lost 10 pounds more than group 2. And it happened to be the single time we ran the actual experiment, and not when we did the simulations that we did afterwards. Okay, so what does that tell us? So the simulations tell us that a difference like this would happen rarely with these specific participants. A difference this big would happen very rarely with these participants if the weight loss drug was just as ineffective as a placebo. All right. So if the drug like the placebo has no effect on weight loss, then it is highly unlikely that we would get a difference this big, a 1 in 150 chance. Now that does happen sometimes, it just very rarely happens. All right. So this part is this is pretty straightforward, okay? I showed you how we could do why these simulations are a reasonable way of looking at how likely each of these differences are on the last slide. So if you forgot about that, then rewind, go look at that. But we can see that if there's no difference, then if the drug is just as ineffective as the placebo, and then we can validly do these simulations, validly just say, Kate, you're a part of group 2, and Lily, you're a part of group 1, and so on, then a difference of 10 pounds is very unlikely. We then go from this step to inferring that therefore it is highly unlikely that the drug, like the placebo, has no effect on weight loss. Because it is so unlikely that the one time we ran the experiment, we just happened to get that 1 out of 150 chance time where you get a difference this big, because that's so unlikely, we therefore conclude that it was not due to chance. It was not due to chance, and what was really going on was that the drug actually did help the people in group 1 lose weight. All right. I could repeat myself, or you can kind of go back, rewind, and rewatch this. I'm telling you, this is kind of mind stretching stuff. But the idea, I'll repeat myself one more time, then I'll shut up. All right. I think I did carefully explain why we can do those simulations on the last page if group 1 and group 2 really are no different. If the drugs that group 1 received have no more effect on weight loss than the drugs that group 2 received, then we can go ahead and go through with this simulation. All right, and this will tell us how big of a difference is we can expect in those two groups to occur simply due to chance. All right, now a difference this big occurring simply due to chance is really rare. So we got a difference that big, but we wouldn't expect a difference that big if these two drugs were the same. We wouldn't expect a difference that big, that's very rare, if these two drugs are the same. Therefore, what's likely causing there to be this big of a difference is that this potential weight loss drug actually does help you lose weight. All right. Now, I've been saying that this 1 in 150 chance is less than a 1% chance. The critical value that researchers use as their most lax critical value is a 5% chance. There's a less than 5% chance of getting the data that you did when you assume that the two groups are the same, then what we then go on to conclude is that therefore the two groups were not the same. They did not receive equally ineffective drugs. The one group received a drug that actually was effective, whereas the other one did not.